This is lesson 18G, integration by substitution. It's also called u-substitution. Integration. And it's a technique for integration that works for certain types of integrals. So it works for the kind of integrals that are in the form f of u du, which it doesn't say that here, but that's another way to think of it. So the integral of f of u du. So if your integral is in that form, f of u du, then you can integrate it using u-substitution. An alternate form to think about it is this one here. So f of gx, the gx is the u, times du, and in this case du is the derivative of u. The derivative of g of x is g prime of x, dx. So this part here is this part right here is your du. So this is also saying f of u du, the integral of f of u du. And when you integrate f of u du, you would get the antiderivative, which is capital F of u plus c. The whole trick to this is rearranging your integral and making sure it's in the form f of u du. So step one is to identify the u and to find du. So they say, and then you're going to substitute u in for g and du, and you'll be multiplying by du. You'll see it here in a minute when I do an example. So then you'll integrate, and then at the end, you'll integrate with respect to u, and then at the end you'll replace the u with whatever u, in this case g of x. Okay, let's go ahead and do it so you can see. So the first example will be, so we're going to start off easy. This is actually, this is example 17, never mind. The first example is the integral of the square root of x cubed plus 2x times 3x squared plus 2 dx. And what you want to do is look at this and figure out what the u is. And in finding the u, do you also see the derivative of u? So, of course, I'm noticing right here I've got x cubed plus 2x, and the derivative of that is 3x squared plus 2, and so I notice right here this is du. My u then, and this is the step, this is a really simple one, so you wouldn't have to do these steps, but for the harder ones, the steps are very helpful. So I'll just go ahead and show them. So the first step is to identify your u and write that down. The other thing too, the u is often in the inside function, like the x cubed plus 2x is inside the square root, so it's like the inner function. And then right away, I just look at this u and I take its derivative. I don't even look at the integrand up here. I just look at u, I look only here, and I take its derivative. 3x squared plus 2 dx. It's important to put the dx on there. And then I can look back up at my integrand and see that I have, I'm going to rewrite my integrand, the integral of the square root, but x cubed plus 2x is actually u. And then the du matches perfectly. So this whole thing right here is du. So instead of writing that, I'm going to write du. So what I've done now is I've rewritten the original integrand in terms of u. So this is step one. Then what we'll do is we'll integrate it. So you could probably do this in your head, but I'll just go ahead and rewrite it a little bit first. So the square root of u is u to the 1/2 du. And then you can use the power rule and add 1 to the exponent, so that'll be eu to the 3/2, and then times the reciprocal, 2/3, and then plus c. So that's the second step, is to find the integral with respect to u, notice. And then the final step is to replace the u with what it is. So I've got the 2/3. Instead of u, I'm going to replace it with what it is. It's x cubed plus 2x, and that's to the 3/2 plus c. So here is the integral. And then we're just going to do some more. So this next one is example 18. letter A. We have the integral of 3x squared plus 2 over x cubed plus 2x dx. And you can look at this and you could probably identify a function and you can see its derivative again. Again, this is a fairly simple example. The thing to keep in mind though is when you have a rational function, you often want, most often, in fact most likely, you're going to want your u to be the denominator. So often, or I'll say usually, because I don't want to say always, there might be an exception. Usually choose u to be in the denominator. It's not proper English, but whatever. So the denominator is x cubed plus 2x. So then right away I'm going to take the derivative of that. I'm not going to look at the original integrand. I'm simply differentiating this u. So that's 2x plus 2 dx. Make sure you put the dx. That looks like a division bar, so I'm going to erase it because it bothers me. I was just underlining. And then I'm going to go back up to my integral, and the oh, I did that wrong. That's x. I'm sorry. That's x squared. My bad. Or cubed, I mean. That's x cubed plus 2x. So this is incorrect. You probably already noticed that. 3x squared plus 2. Okay, so now looking back up at the original integrand, I see that the 3x squared plus 2 dx is right here. So that entire part is now du over, and then the denominator is u. By the way, if there was extra stuff up here in the original integrand, then you wouldn't be able to use u-substitution. It has to, this whole thing has to be totally converted into du over u. Anyway, so now second step is to integrate that. Hopefully you recognize that that's going to be the natural log of the absolute value of u plus c. And then finally replace the u with, in this case, x cubed plus 2x, and then plus c. What if we have the integral of x e to the 1 minus x squared dx? So earlier I mentioned that you want to choose your u so that it is an inner function. And in this case, we have a product, and we also have e to the to a function. So this 1 minus x squared is an inner function because it's e to that function. And you might also notice that if you took the derivative of x squared, you're going to get x to the 1. So hopefully you're noticing that a logical u would be u equals 1 minus x squared. And again, if you try something, if you try u and it doesn't work, you can always try something else. So you just have to trial and error a little bit. Okay, right away I take du. I don't even look at the integrand, I look at u. So if I differentiate u, I'm going to get negative 2x dx. Okay, if I look up at the integrand, that doesn't match it exactly. But I do see here I have x times dx. So like I could rewrite this as the integral of e to the 1 minus x squared x dx if I wanted to, by the commutative property. So if I'm rewriting this integrand, I could just start, I've got the integral of e to the u, and then x dx, if I look back over here at this statement right here, I hate to underline because it looks like a division bar, I could solve that for x dx. So if I divided both sides, if I divided both sides by negative 2, I would get du over negative 2 equals x dx. And then I can replace the x dx with du over negative 2. And instead of dividing by negative 2, I'm going to put it as 1 over negative 2 out front. So it's okay to have a constant out front. Everything has been rewritten in terms of u. And now we have completed step 1. So then step 2 is to find the integral. The constant can just hang out in front. The integral of e to the u du is e to the u plus c. So I get this when I integrate. And then the final step is to replace the u. Negative 1/2 e to the, what was u? 1 minus x squared, and then plus c. Okay, so far all of these have been, slightly different. And now we'll do another example, another problem with a trig function. Integral of cosine cubed of x sine of x dx. So I'm going to say try this one on your own and then come back and watch the explanation. All right, so if I look at this, cosine, the derivative of cosine could be written in terms of sine, and the derivative of sine is also in terms of cosine. So logically, you could choose either one of these as u, but you want to choose the one that's the inner function. So the inner function is cosine of x because it's being cubed. So that's the one you want to use for u. So I write down u, then I find its derivative. I don't even look at the integrand. The derivative of cosine is negative sine of x dx. Okay, then I go back up and I rewrite. So I've got cosine of x cubed. So cosine of x is u. That means that's u cubed. And then sine of x dx, this is sine of x dx. If I divide by negative 1 or move the negative 1 over, I get sine of x dx is equal to negative du. So therefore, I'm going to be replacing this whole thing with negative du. So I'll put the negative out front and then multiply by du there. Okay, so I've completed step 1. I've got it rewritten in terms of f of u du. And now I can integrate. So using the power rule, add 1, divide by the new power. There's still a negative tagging along out front, and then plus c. And then the final step is replace u. So u is cosine. And it's done. Next one, again, I'll write it down. I would like you to try it on your own first and then watch the explanation. All right, so here's the explanation. Hopefully you've already tried this on your own. I talked earlier about when you have a rational function, you want to try the denominator, make the u be the denominator. So in this case, u would be sine of x. Okay, I take the derivative of sine, I get du equals cosine of x dx. Well, this looks like it's going to be a pretty straightforward one. So I've got the integral. The cosine x dx is du. And I've got sine of x on the bottom, which is u. So now we can integrate. We know that's natural log of the absolute value of u plus c. And then we simply replace u with sine of x plus c. Well, that wasn't very challenging. But, let me see here. I think that's it. Looking through the book. So, yep, that's it for u-substitution.